Hey guys, in today's video, we'll be talking about Leetcode problem 22. It's called generate parentheses. So the description is given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. And what well-formed parentheses means is that you have to have a opening before closing. And let's see the example. If the n is 3, we have to have 3 openings before closing. So, but not necessarily all closing has to occur at the end. You can see right here, we have one opening, another opening, and then closing. So that makes a valid parenthesis. And we have opening and closing right here. So that's good. And now we have closing for this first opening one. So that's good. And you can have all combinations of that we want to return here. If the n is 1, we just have one combination that we need to return. Cool. So anytime you guys see a question like generate all combinations or generate all permutations of a particular array, we have to think about backtracking. And we're going to solve this question using the backtracking algorithm. So let's jump into the whiteboard to understand how we can tackle this problem using backtracking. So we're given n3 in our first example. So let's see what can we do with the n equal 3. So what that we have 3 openings available and 3 closings available. So in backtracking, how it works is that you need to make a decision, and then if the decision meets a criteria, you keep on recursing on that, or you fail at that level. So what I mean by that is that, so for example, you have 3 openings and 3 closings here. We can try to pick opening one, or we can try to pick closing one, but you can see that closing does not work in our case because we have 3 and 3, and if we take closing first, then we're going to end up with non-well form. So that's our constraint. So in this particular instance, we're going to end up picking just the opening one, right? So for example, let's say we pick open parentheses, and then now we have 2 open parentheses left and 3 close parentheses left. So once we have that, we can make another choice now. So what kind of choice can we make? We can take another open one right here. So now we have 1 opening left and we have 3 still closing left. And or we can make another choice right here, which is we can take closing right here, which is fine because we have more closing than open, so we can close it for the ones that are open already. So in that instance, we have 2 openings left and 2 closing left, right? So for this tree right here, we can make 2 more choices. We can take either opening or closing, right? So for example, if we take opening, now we have 0 openings left, and then we have 3 closing left, or we can have closing right here. In that instance, we'll have 1 opening left and then 2 closing left, right? So we can keep just recursion going. In that case, we have no openings left. We have 3 closings, so we can pick closing here. So we'll just do that, and then we have 0 opening and we have 2 closing. That tree is gonna end up in where we have 0 opening and 0 closing, right? And if we follow that, we can have opening here, and in that case we'll have 0 opening and we'll have 2 closings left. Or we can pick closing here because we are openings are less than closing. So I mean, sorry, closing, yep, openings are less than closing. So let's pick closing here. We can do something like that too, and then we have 1 opening left, 1 opening left, and 2 closing left. So you guys can follow the pattern here, and the base case for our recursion function would be this right here, when we have 0 opening and 0 closing, and at that point we can tell that we have a well-formed parentheses, and we can add that to our result set. Hopefully that makes sense. Now let's jump into the code. Okay, so we know that we're gonna have some sort of recursion function, so let's just write that first. Void backtracking, I'm just gonna call it, and we know it's gonna take some sort of working set, and then we know it's gonna take open count, we're gonna take close count, and we're gonna take something that holds our answers, right? So the base case for our recursion function would be if open is 0 and close equals 0, then we can say that our working set is fully well formed parentheses, and we can add it to our answers, right? And now we can make those two decisions, but we can only take two decisions if the openings are smaller than closing. Otherwise, if the open and close are the same, we have to take open first. So let's tackle that one. If open equal close, then we have to take the opening first. So we can say backtracking working set, we can add open here, and we can say open -1 now, and then close and answers. Now we can take any decision, right? We can take either opening or closing, but we cannot take open if there is no open left. So if open is greater than 0, then we can say backtracking working set open -1 close answers, and if there is any closing left, backtracking working set plus, we're gonna pick closing here, and then open count stays the same, close count decreases, the answers same. So I think that is all we need for our recursion function. And now let's see what we need here to call it with. So we definitely need a answers list of string, and we need to call that function now. Backtracking initial working set would be empty, and then open count we have n, and we have close count for n, n being the close count as well, and we can pass our answers along. And after that function, we should have our answers fully built out. So we can just say answer right here. So let's give that a try. Perfect. Let's try to submit it. Boom. Well, cool. Well, thank you guys for watching. I hope you like this video. If you do, please hit the like button and subscribe to my channel. It really helps a lot. Thank you. Bye.